the last section of this video is for boiling point elevation and freezing point depression is this problem. Okay, so I have a mass of a compound, which we're going to say X, is 2.50 grams. It has an empirical formula, I'm going to call it EF, of C6H5P, so this goes back to 1211. I have a mass of benzene, is 25.0 grams. And I have a freezing point of 4.3 degrees C. And it tells me that the TF of pure benzene, TF naught, is 5.5. So that will always be given to you if it's not water. And the KF, which regardless of what it is, will be given to you, is 5.12 degrees C per mole. And it wants to know what the molar mass is. I skipped that part. And what the molecular formula is. Okay. So I need to start this by finding out what my delta TF is. So my delta TF is TF of the pure minus delta TF. So it's going to be the 5.5 minus the 4.3 to give me 1.2 degrees C. Okay, and since this is a freezing point problem, so delta TF is KF times F times CM. So I have 1.2 is equal to 5.12 CM so 1.2 divided by 5.12 gives me CM, and so CM ends up being 0.2344 molal, or small m. Okay, and I know from previous parts of this chapter that CM, or the molality, is going to be the moles of X over the kilograms of benzene. So I have 0.2344 is the moles of X. That's what I don't know, because I have a mass of benzene of 25 grams. I've kind of not left myself room, but that's 0.025 kilograms. So 0.025 kilograms. So moles of X is 0.2344 times 0.025. Go back up here to the top. So moles of X then is 0.005859 moles. And of course, moles, or N, is the mass divided by the molar mass. So I have 0.005859. The mass of X was given to me as 2.5 grams divided by the molar mass. So when my unknown is on the bottom, I want to multiply both sides. So 0.005859 molar mass is equal to 2.50. So my molar mass is 2.50 divided by my 0.005859, and I get 427 grams per mole. So that answers the molar mass part. Now this goes back to chapter 4, which is kind of why I threw this problem in. To find the molecular formula, I need to find out how many of these are there in this. So I need to find what they call the empirical weight, which is just basically the molar mass, but it's the molar mass of an empirical formula. So I have 6 times the 12.01 for carbon, plus 5 times 1.01 for hydrogen, plus the 30.97 for phosphorus. And when I do that, I get 108.1. And so it's another N, it's a different N. N is the molar mass divided by the empirical weight. So it's the 427 divided by 108.1. And when I did that, I got 3.95, but I'm going to round that to 4. So basically it's 4 times the C6 H5P, which means that I do 4 times 6, so C24. 4 times 5 is 20, and P4. And this is a 4, not a 9. It kind of bled over there. There you go, 24. So the answer, I got much more room over here, C24, H20, P4. That's my molecular formula. Okay? So I often ask to find the molar mass, but this one added the whole thing about the molecular formula in there, so I like that too. So that is the end of the section about the boiling point elevation and freezing point depression.